Hey everyone, thanks for coming. I'm Seth. I'm going to talk to you about Archetype. And we're building a secure software supply chain for the sovereign web. Oh yeah, you want to play. So this is our dot post. Yeah, basically, we've been in the Urbit community for a bit and been working on this project. It's kind of been this mind virus that has been around for several years, just kind of surfacing over and over again. But past couple of months, we started working on it formally with UAC, the Urbit Accelerator program. And so we want to say what up. This is what we're working on. And so our team, me, doplyr-harbur, Seth, I came into Urbit through the crypto space. I was doing sort of mechanism design, protocol architecture, and smart contract development, and generally building things in Web3 since 16. When I joined the network, Urbit, in 2019, I started hanging out with the guys at Dalton Collective, and eventually got kind of deeper into Urbit and built a portal earlier this year. And then we have Sornev. This is Corey, and he also got into Urbit through crypto. He was working on R&D in the space, governance, ZK proofs, then we have AJ, hastyp-patmud, and he was working on e-commerce in Web 2. And at GoPuff, he was building scalable e-commerce infrastructure, and he built Plug, which is an Urbit app that lets you create self-hosted e-commerce shops. Cool. Yeah, this is our dot post. And yeah, we hope to be a good neighbor. And so, yeah. So what are we building? First thing, decentralized package management infrastructure and an Urbit dev suite. And these two things are related, and we're going to tell you sort of how. Yeah. So coming from a crypto background, I think about kind of I was always interested in building on top of these, sort of new properties that you got from blockchains. Bitcoin, love Bitcoin, right? Big orange coin fan. But the problem is, in terms of a development paradigm, you don't have state, right? So UTXO model doesn't really lend itself to building applications. So 2015, we got Ethereum, and Ethereum has Turing complete smart contract programming language, and you can write all kinds of stateful contracts and build all kinds of interesting things that take advantage of the properties of blockchains. And yeah, and with great power comes great responsibility, and you get the DAO, right? And you guys know the DAO, right? What is DAO? May never die, but yeah. So code is now money, but bugs can cost millions. The DAO, they were trying to build this venture capital firm that's decentralized, and strung together all this different code, and it's acceptable for code to have bugs, but on smart contracts, on blockchains, those bugs are incredibly costly. So $150 million and maybe this existential risk for Ethereum by hard forking the actual chain and reversing history. So this whole idea of move fast and break things, it's a fun concept in Web 2, sort of a Silicon Valley orthodoxy. Just kind of go and you can fix things on the fly, but actually in Web 3 that doesn't really work, because you're playing around with real value, and the scale of just how much you can fuck up is quite different. And so what does Web 2 do about this? Web 2 is a more mature software ecosystem, and so they have sort of strategies that they've leveraged over the course of many years. One of those is package management. And NPM, they're kind of like an archetypical package manager. And so the JavaScript ecosystem has become one of the most vibrant developer ecosystems to exist. You can find packages for everything, and it helps you, modularize your code, get strong separation of concerns, and really leverage the advantages of open source as well as like strong software development practices. But you get things like this. And for anyone familiar, this is a package called leftpad. And what leftpad does is literally exactly what's on the screen. This is the entire package. It moves spaces. It basically pads, a string. And so obviously, core piece of infrastructure that everyone needs as a dependency. That's a joke, by the way. But this guy who created leftpad, he is this, software developer who, built a lot of stuff for open source, and he had like 250 different packages. One of them was like this, like CLI, and it helped you kickstart your projects. He called it Kick, and so Kick, the company that does like messaging, whatever they do, they complained to NPM and were like, "Hey, take him off the registry. We don't want that." And Kick was successful with that, and so they ripped out the package. And so in response, this open source software developer was like, "You know what? I want open source, and I need to liberate all my packages." So he just ripped them off the registry and basically rugged anyone who had this package as a dependency. And so, this one package, this one dependency that he made for string manipulation, wound up becoming depended on by projects like React, Babel, this core sort of like JavaScript, sort of dev toolchain, right? And all of a sudden, like, none of these packages could be, none of these, sort of projects could even be built, didn't pass CI, and swaths of the internet went down. And basically, this one tiny little package that does string manipulation wound up infecting the web. And so what are some learnings from that, or things that we can say? Well, one, Kick shouldn't have been able to bully smaller players, right? There shouldn't have been anyone in a position, in the centralized position, to say, I'm going to rip this off, I'm going to rip this out, and basically an axis of pressure. And the dev himself shouldn't have been able to unpublish, right? Because this is, a dependency that many people are relying on, and so you shouldn't be able to rug. So what do? So package management, good, yum yum, but that's still like a good thing to have. Package management, it allows you to do a lot of really solid things, but we can do all this while fixing some of those problems. The key thing is to secure the root node of the software supply chain. And so there are 3 components to our solution. One is a global type registry. 2, there's a metadata graph or metadata layer of semantic context. And 3 is a curation layer. And so GTR, the global type registry, there are some properties that we want out of the system. So one, it should be immutable. You need to have permissionless publishing. It should be highly available, completely rug-proof, and maximally decentralized. Then you have the metadata graph. And so the metadata graph is kind of like this layer where you can link arbitrary metadata and context associated with packages. And so that's things like security assessments, reports, audits, attestations, claims. And then you have the curation layer. And the curation layer is kind of this, it's the incentive fuel, right, for incentivizing sort of high-quality primitives and packages, as well as context, onto the metadata graph. And it also gives you sort of the tools and sort of like language and ontology for discoverability, as well as the different pieces of software that actually allow that. And so to talk a little bit more about the type registry and some of the considerations for getting that right, Corey's going to tell you a bit more about that.
Great. I'm Corey. So what do we mean by type introspection? I mean, type is an overloaded word, a dirty word here. but basically there's a couple standards that exist in Solidity development. If you guys are familiar, ERC 1820 and ERC 165. And essentially, they have code very similar to this, right? You can support an interface. You can query a contract address, right? And you can see whether or not this contract conforms to a set of methods in an ABI interface, right? But instead, what we want to do is expand that functionality in order for there to be this strict support. So basically, for this ABI, it does nothing more than what this specific ABI specifies, right? This is what the registry contract leverages. And you see this code everywhere, right? Interface, type, so contract, arbitrary address, right? And now you have this kind of guarantee that this address you're calling, right, only performs the methods specified in this given ABI, right, and nothing more, nothing less, right? And you have this audit trail to go and look in the registry with the metadata graph to ensure that there's no obfuscation through naming, methods, et cetera, right? And one thing about that seems also kind of lacking is, you go on the Etherscan, right, and you can see a verified status of a contract, right? But we have no canonical list of addresses pertaining to a given deployment. So what that means concretely is how many times has the ERC20 factory been deployed, right, onto the chain? We can't surface this, right? There are some stuff that's already done in the Solidity compiler for libraries, but we don't really have a canonical list of addresses, right? And the registry will help with that. So once packages are published, once deterministic builds are made, they can be added to the registry, and then contracts can call them. And essentially, this is like a fail-safe, right, such that contracts will revert if any of these checks are violated.
Ultimately, we should probably talk about Urbit. After all, this is a clean slate OS for the 21st century, and we are at a Urbit assembly. So Urbit, how this idea of blockchain-based package management ties in is a little bit different than the benefit that you get in Web3 world. In Urbit world, it's really about making composability real. And so to that end, we're working on an Urbit dev suite, because ultimately, if you're going to be consuming and publishing packages, you need a place in order to do that from, as well as a place where you can make sure that you're consistently using primitives in the same way that other people publishing or consuming your primitives are. And really, that means you want to do 4 things. You want to be able to create, compose, test, and deploy. Generate an Urbit project with sensible defaults and a project structure set up for this type of package management and composability. You want to be able to grab packages seamlessly, install and run them on your test ship or fleet of test ships locally as you work, and then ultimately deploy. And here, for us, deploy means both publishing your Urbit app to a distribution ship so users can get it, but also for any primitives that you've built into your Urbit app that you want actually developers to consume, you should be able to publish that to the registry at the same step that your app goes out to users. Ultimately, though, everyone kind of has lots of opinions in Urbit land, lots of favorite tools and stuff that they want to do. And so the tooling that we're building, it isn't so much a new Urbit tool as it is like an opinionated set of full stack framework that just pipes existing Urbit tools and other Urbit tools for development that are being worked on in one cohesive way. And so it's really choose your own adventure. We believe you should be able to build on Earthside if you want, Marsside if you want, and then use any of the languages that you want to build your app with, no matter what that looks like. So you can pick any path through this graph, really. If you want to only be using JavaScript, you can create an Urbit project through a CLI Earthside, write your code with JavaScript, and use an Urbit database as a service like Tome, Bedrock, Obelisk, that kind of a thing, where you're not necessarily doing a ton on the back end. Or alternatively, if you are a Hoon maxi, you may want to actually just clone a desk in a development ship write your Hoon there, and even you want to maybe build the UI in Sail instead of JavaScript or React, and you should be able to do that. Or if you're like me, you maybe want to take a hybrid approach. You maybe want to be able to develop in either of those environments, depending on what part of the software development lifecycle you're in, and use Hoon for the back end, JavaScript for the front end, and Sail if you're running a web server on your Urbit. Ultimately, what we're working on right now is actually this first path through. This is sort of the lowest lift way to like test this whole the set of standards and framework that we've built. So we're working on a CLI called Golem that lets you create Urbit projects from Earth with templates. The templates are for the desk, for UIs, and you basically can have a reasonable starting off point, whether that's like CRUD or like a web server, and then keep iterating from there using these standards. And you get all of these things there, right? You can test creation, composition, testing, and deploying with that first like hybrid workflow. What that looks like on the Unix side is what I described, generating with the CLI, using the either desks or libraries to like import files, building a production fleet, and then deploying. On the Urbit side, you can do something with a similar structure. You clone a desk, test on your ship, make sure that dependent agents are installed, and then deploying from Urbit side can actually be as easy as running Treaty, right? But ultimately, the structure is the same. So I like to call this sort of the gigabrain view of how this works, right? We have a set of like standards and opinions about how all of these pieces most easily fit together, all the tools that everyone else is working on. We put that into a framework that can be used from either of these environments so that you can operate with like Hoon and scaffolding or JavaScript and just use Urbit as a BAS, backend as a service. And then your UI can either be in React or Sail or both potentially. But with both of these paths, you get the same core software development lifecycle: creation, composition, test your Urbit app, and then deploy it to the distribution ship, as well as sharing any primitives on the registry. And so just like the last diagram, this is what we're working on right now, right? We have the standards, we have that framework, at least the first version that we're soft launching today. And with the CLI, you can scaffold and build projects and then run them. It helps you run them. And so with that, you get sort of this like creation and testing piece. And once the registry itself is actually on a testnet, today we're soft launching the white paper. Once the registry is on the testnet, the CLI will also be able to fulfill sort of those last two grayed out parts of this life cycle, which is consuming packages from the registry, browsing them, and then also publishing any primitives that you built yourself. All right, and I'll hand it back to Seth to talk about what we just went through.
Cool. Yeah, thanks, AJ. So yeah, we really like Urbit, and like you might be thinking like, what does Urbit have to do with this sort of like, or like where does it fit exactly into the stack of not just using the global type registry, but how can Urbit specifically kind of help? And so like determinism and sort of the properties that you get from Urbit, you have this sort of ability to kind of get repeatable builds and lots of interesting kind of guarantees. And we see this as kind of like a place where you can do interesting things. There was a panel, an hour or two ago on sovereign AI, and we think that basically like a couple of the pieces of infrastructure that we're building are actually really interesting for attacking that problem. And so Urbit as this kind of like place to sort of have your sort of like your homie, right? Your buddy that can kind of like do things on your behalf, interact with all kinds of AI agents, right? Like that really requires a secure software supply chain, right? You need a model, you need agents that are not going to hallucinate because they're playing around with stuff that is deeply sort of core to who you are and deeply personal and should be private, and all of your interactions need to be secure. And so we keep these properties in mind, and we're building this infrastructure, and sort of on top of it, there's a lot of other interesting things that we can do. And so we're going to take the ball of mud that kind of comes from, this, over-reliance, perhaps, this exuberance in this JavaScript ecosystem and kind of, sort of going too far with package management. And we're going to kind of like, harden it, and pack it in and make these kind of diamond hard primitives, right? And, we'll take those diamonds and, as we add this sort of metadata, this context, and have these more networked like set of dependencies and key software primitives, we can kind of like crystallize outwards along this sort of like commons and dependency graph. And so, we're looking to, we're at Urbit assembly, right? And so like we're this 1,000-year computer, this will turn into, that requires a secure software supply chain. So we're looking to build the 1,000-year software registry for this. And so, we've, built some stuff on Urbit before, and, there's something that Ted says sometimes, rage-driven development, right? And kind of like the things that annoy the hell out of you are like great targets for building software, right? And building solutions for. And so that's what we do. And so like, there were things like in the Urbit development process that annoyed us, and we're looking to sort of solve the problems associated with software development there. And so if you have any things that annoy the hell out of you, we'd love to hear about it. We're going to be at assembly the rest of the week / Urbit week. You can find us online at archetype.computer. And there you can find the draft, sort of V0 of the GTR white paper, as well as, and then you can, on GitHub, find Golem, that's our CLI, the dev suite that AJ was telling you about. And then hit us up on Urbit. We're on groups. Come say hi. And these are the links. And yeah, thank you.
Do we have time for Q&A? Yes?
Cool.
Great. So yeah, we would love to answer any questions if people have any.
Yeah, I'm just curious, because it's very decentralized. One of the benefits of the centralized system is it prevents people from like sending spam packages that are developed to destroy your product, right? What sort of like resistance do you have against somebody basically like maybe coming up and launching 1,000 Ether.js?
I mean, I can kind of. So we want to leverage like the existing public key infrastructure that exists around packages today, right? Developers sign their packages, right? And there are releases, there are code repositories. So if you're kind of familiar in the Arch Linux world, there's like the AUR, right? And that has spam in it, right? That has developers releasing packages on behalf of code repositories that they don't own and they don't actually publish to, right? And so part of this curation layer, right, is that making that like a first class conception, a primitive that we can use and surface right on an Explorer, right? So one would be able to see as part of the registry the signing keys for these package manifests, right? And then it is up to the user to make this discernment about whether or not they want to bring this package into their project.
Right, so we're surfacing all of the relevant context, right? There is permissionless publishing of packages, but we're surfacing context that, itself, there's permissionless context, but there's also some like metrics that are just like really useful, and other pieces of context like existing public key infrastructure, right? That exists on all of these different software ecosystems. And we're going to connect all of those things, right? And so what that could look like is something like, an extension of sorts, right? A browser extension, or if you want to run it on your CLI, basically just kind of like verifying the cryptographic signatures associated with packages across all the different registries of the different software ecosystems, right? There's also sort of like subjective data that is interesting, right? And so this can leverage things like reputation graphs and other kind of interesting sort of like solution spaces that we're interested in, and us, the team, have kind of experimented with over the years. There's lots of interesting context that you could provide to tackle this question of sort of curated software or packages, right? And so the discovery is also this other thing. And so each person, each individual has their own set of things that they value. And so we want to respect that. And so on Urbit, like on your personal server, you should be able to take the things that you care about, your intents, make them intelligible, right? And basically be able to use the ontology and the different kind of like pieces of context that exist on this metadata graph as well as the metrics, and like tie them together and find exactly what it is you're looking for, so that like the equivalent of the check mark that is on Twitter, verified, right? This is a personal question, right? And so you can find your personal check marks for the different things that you care about.
Yeah, one way like to concretize a bit, of how technically it's being achieved is, often when you use a package manager, right, like these packages are signed, right? The signatures are checked against in the CLI tool, right? So we're going to have this like same notion, right, in this world. But then there's also this notion of claims, right? People may want to say, oh, I've checked this package, right? And then it's up to the user to trust these claims. And so this kind of goes more into, this is something that's elaborated a lot more in the white paper about commitment statements, right? That can be things that can be said about the metadata graph, and proofs, inclusion proofs that can be put on chain, right? That can be audited. And this just so happens to be kind of the base layer needed, right, to kind of get us off the ground and start building like a trust graph.
Yeah, and you can associate like actual kind of like audit like reports. You can do sort of formal verification, property testing, all the kind of security assessments that you would want can be linked permissionlessly to the actual packages, so you can have that context like deeply associated. Nice. And yeah.
Cool. Do we have more questions?
Yes.
What versioning scheme require your package management solution? Versioning scheme, like semantic versioning?
Yeah, we have like a pretty agnostic opinion on
this.
Yeah,
we're agnostic about this. Basically, it's like you can have different versioning schemes, right? And we will surface that information, right? And like this is generally kind of like core to our philosophy, right? Is that like anyone can do what they want, right? Like you're a software developer, you have your own kind of set of experiences and things that you like to do, and use those. We'll surface the differentiating factors, right? And so we'll show you if you want semantic versioning, you can use that. If you want Kelvin versioning, you can use that. And we'll surface that information because actually it's very important context, right?
Yeah, the standard that we have even, I mean, it's just a standard, right? If someone chooses not to conform to it, they may not be able to have access to some of the curation mechanisms that we're providing, right? But it won't prevent anyone from publishing or using the system.
Yeah, the other thing is that like basically like you won't be subscribed automatically to updates for packages, right? Like you signed up for a certain version and like, well, you can but that would be like an additional step. By default, you're not, signing up for automatic updates, but rather you are attaching as a dependency this immutable kind of linkage to a piece of code that you rely on that works in a certain way, but otherwise you can take you can make the choice to upgrade or not.
Thank you.
Anybody else? Oh,
cool.
yeah, great.
That's it. Sorry, guys.
Thank you.